Hey, looks like the same learning target. Let's see what the new twist is today. Hey, it looks like it's one of our friends. It's a difference of cubes, right? We're looking at u to the third minus v to the third, because 512 is just 8 to the third power. So u minus v will become x minus 8. U squared will become x squared. Now we got to flip the sign, so be positive. U times v, well, x times 8, we'll write it as 8 times x, 8x. Last symbol is always positive, so we'll put a plus. V squared, well, 8 times 8 is 64. And so we've got x minus 8 equals 0, and then, oh my goodness, the other part does not factor. So we know it's going to be quadratic formula, right? First solution is 8. Then we got to use the quadratic formula. So we plug in some numbers and we keep going and we keep going. And oh my goodness, inside the square root symbol, I see a negative 192. That is a negative number. How are we going to tackle this? Well, I can factor 192, right? 64 times 3 is 192. And of course, I want to use 64 because that's the largest perfect square that's a factor of 192. Hopefully you remember this from either first year algebra or maybe even pre-algebra. But then there's that negative symbol, so I got to think of it as being times negative 1, right? So 64 times 3 is 192, and then times negative 1 makes it a negative 192. And the neat thing about this is we can take the square root of negative 1. The square root of negative 1 is the number I. That's an imaginary unit. In other words, I squared equals negative 1. Okay, so our imaginary number I, our imaginary friend. So now we have the ability to simplify. Square root of 64, of course, is plain old 8. Square root of negative 1 is the imaginary number I. Square root of 3, we're stuck with that. Finally, I can divide by 2. Negative 8 divided by 2, of course, is negative 4. 8i root 3 divided by 2 leaves us with 4i root 3. And so we've got 3 answers. Notice instead of trying to go from least to greatest, I listed the 2 numbers with our imaginary friend I, and then I put the real number 8. Those are actually called complex numbers when we have the imaginary number I mixed together with real numbers. All right, so if we have real numbers and imaginary numbers mixed together, those are complex numbers. Hopefully you remember that from first year algebra. And so I got 3 answers, 2 from the quadratic formula, 1 from the factoring. This time we'll take a look at a sum of cubes instead of a difference of cubes. Right? Instead of a u to the third minus v to the third, this time we've got a u to the third plus v to the third, because 1,000, of course, is a perfect cube, 10 to the third power. So our u plus v becomes x plus 10. U squared will be x squared. We've got to flip the sign, so it'll now be negative. U times v, well, x times 10, we write the result as 10x. The next symbol is always positive. V squared, 10 times 10 is 100. Again, I've got 2 factors I can take care of. The first one, x plus 10, piece of cake, we get negative 10. Second one, again, quadratic formula time. Got to plug in some numbers. Start simplifying. Holy cow, negative 300. Well, the greatest perfect square that's a factor of 300 is 100. So 100 times 3 makes a 300. But then, of course, we also need the negative 1. Square root of 100, of course, makes 10. Square root of negative 1 is I. Square root of 3, we're stuck with that. Simplify. I end up with 5 plus or minus 5i root 3. So one solution is 5 minus 5i root 3. Next solution is 5 plus 5i root 3. And then, of course, we have a solution of negative 10, which we got from the factoring part. All right, so two solutions from the quadratic formula, one solution from the factoring. One more just for fun. We got to use the third minus v to the third. But, oh, let's pretend I don't notice it's a difference of cubes. I can go to synthetic division, and I can get my first answer from synthetic division. I say, hey, look, I got a solution of 4. But now, of course, I'm still left with 1x squared plus 4x plus 16 equals 0. That will not factor, and so I still am resulting to use the quadratic formula. Same situation, I'm going to get a square root of a negative number. I'm going to use 16 times 3 for 48 because 16 is the largest perfect square that is a factor of 48. And then I can take the square root of 16, I get 4. Square root of negative 1, of course, becomes I. Divide everything by 2, and there are our second and third solutions. All right, so I've got 3 solutions. 2 of them came from the quadratic formula, and then 1 of them came from synthetic division. So if I don't recognize it as being a sum or difference of cubes, synthetic division can always come to my rescue. And so it is time to practice.